Time feels obvious. It moves forward, 1 second after another. You remember the past. You experience the present. You anticipate the future. That's just how it is. Everyone knows that. But that's not an explanation. That's a habit. And habits are dangerous because they feel like understanding when they're really just repetition. Richard Feynman warned us about this. Not with alarms or manifestos, but with quiet insistence. He kept pointing out that time is the thing we use to define motion, change, and cause, yet we almost never ask what time itself is. We treat it as a background, a stage on which the universe performs, solid, invisible, unquestioned. And that should bother you. Think about how you usually imagine time, a line. The past behind you, the future ahead, you move along it whether you like it or not. You can't stop, you can't turn around. That picture is so deeply embedded that even physicists slip into it when they're not being careful. But the universe does not owe you a picture that matches your intuition. Start with something simple. Motion. You say an object moves because its position changes with time. That sounds reasonable. But notice what you just did. You define motion using time without defining time. It's circular. You say time passes because things change, and things change because time passes. That's not an answer. That's a loop. Newton was the first to formalize this picture. He assumed absolute time. A universal clock ticking the same for everyone everywhere. Planets move through space as time flows uniformly beneath them. This worked spectacularly well. It predicted orbits, trajectories, tides. For centuries, nobody questioned the clock. Why would they? Everything else seemed to work. But cracks appeared. Small ones at first. When scientists began measuring things very carefully, they noticed something strange about light. It didn't behave like ordinary motion. No matter how fast you moved, light always appeared to move at the same speed. Not faster, not slower, always the same. That alone should have been enough to cause panic. But instead, people tried to patch the old picture. Maybe light moved through a medium. Maybe clocks were wrong. Maybe the measurements were flawed. Anything to save the idea of absolute time. Einstein didn't do that. He took the measurements seriously. And when he did, time broke. He realized that you can't keep a universal clock if the speed of light is the same for everyone. The math won't allow it. Something had to give. Either the experiments were wrong, or time itself was not what we thought it was. Einstein chose the second option. Here's where Feynman steps in decades later, trying to explain just how radical that choice was. He emphasized that time is not something that flows independently. It's part of a structure. Space and time are welded together. You can't talk about one without the other. Think about this. Two people moving relative to each other will disagree about whether two events happened at the same time. Not because of delay, not because of signal travel, but because at the same time is not an absolute concept. There is no single universal now. That statement alone should make you uncomfortable. It means the present is not a shared slice of the universe. It depends on how you move. Most people hear this and say, sure, but that's just a measurement issue. No, that's not an answer. Measurements reveal structure. They don't create it. Time itself adjusts. Clocks moving relative to you tick more slowly. This is not an illusion. It's not about perspective. The clock genuinely accumulates less time. Bring it back. Compare it side by side with a clock that stayed behind, and it will disagree. That disagreement is permanent. Feynman loved to stress this point. If you think time dilation is just about observation, you've missed the point. The clock experienced less time, period. Now pause and think about what that means. If time were universal, river flowing everywhere at the same rate, this would be impossible. You can't have one part of a river flowing slower than another without changing the river itself. And that's exactly what happens. Time is not a river. It's more like a dimension. And you don't flow through it unless you're moving through space-time as a whole. Here's the strange part. You are always moving through space-time at a fixed rate. Always. If you're standing still in space, all your motion is through time. If you start moving through space, some of that motion is diverted away from time. You move through time more slowly. This is not philosophy. It's geometry. Feynman warned that once you accept this, your everyday picture collapses. The future is not something you are approaching. It already exists as part of the space-time structure. The past is not gone. It's still there, just not accessible. People resist this idea fiercely. They say it destroys free will, or meaning, or common sense. But the universe does not negotiate with common sense. Think about causality. You believe causes come before effects. That seems obvious. But before is a time word. And if time ordering depends on motion, then causality is more subtle than you think. In relativity, different observers can disagree about the order of events that are not causally connected. One observer says A happened first. Another says B happened first. Both are correct. There is no absolute ordering. What saves causality is not time, but structure. The speed of light sets a limit on how influence can propagate. Causes and effects must lie within each other's light cones. Outside that order is meaningless. Notice what just happened. Time did not enforce causality. Geometry did. This is the deep contradiction Feynman kept pointing to. We think time causes change. Physics says change is constrained by space-time structure, and time is part of that structure, not the driver. And it gets worse. In quantum mechanics, time plays an even stranger role. The equations that describe fundamental processes work perfectly well forward or backward in time. The laws don't care which direction you run them. The basic rules are time symmetric, so why do you remember the past, but not the future? Why does entropy increase? Why does time feel like it has a direction? This is where Feynman was particularly blunt. He said we confuse the laws of physics with boundary conditions. The laws don't tell you which way time goes. The universe's initial conditions do. In other words, time doesn't flow because physics demands it. It flows because the universe started in a very special state. That should bother you. It means the arrow of time is not fundamental. It's emergent. A consequence, not a cause. Think about a broken cup. You drop it, it shatters. You never see the pieces spontaneously reassemble and leap back into your hand. Why not? The laws allow it. Every microscopic interaction is reversible. The answer is probability. There are vastly more disordered states than ordered ones. The universe naturally evolves toward what is more likely. That statistical tendency is what you experience as time's direction. So your sense of past and future is tied to entropy, to memory, to records, not to a universal ticking clock. Feynman warned that once you see this, you can't unsee it. Time stops being a thing and becomes a bookkeeping device, a way to organize change under specific conditions. Now return to your own experience. Right now, you feel yourself moving from moment to moment. That feeling is real. But it is not telling you the structure of the universe. It's telling you about how your brain works. Your brain stores records. It compares states. It constructs a narrative. That narrative gives you the sensation of flow. But the equations don't contain that sensation. Physics describes a block universe, past, present, and future all equally real, not stacked in motion, but laid out in space-time. Feynman didn't like mystical interpretations. And he didn't sugarcoat this. He said, if this picture makes you uncomfortable, that's your problem, not the universe's. Now ask the original question again. What is time? The original question is wrong. Time is not a substance. It is not a force. It is not something that passes. It is a coordinate in a structure that relates events. You don't move through time like a boat on a river. You trace a path through space-time like a line through a map. And here's the part most people never hear. If you could see space-time the way the equations describe it, there would be no privileged present, no glowing now sweeping forward, just relationships. This is why Feynman said the past hasn't really gone away. It's still there, in the same sense that distant places are still there even when you're not at them. You don't ask where yesterday went. You ask where Paris is when you're not in Paris. Time works the same way, except your intuition refuses to cooperate. And yet, experiment after experiment confirms this picture. Atomic clocks flown on airplanes come back ticking slower. GPS satellites must correct for both velocity and gravity, or they drift miles off target. Particles moving near the speed of light live longer than they should if time were absolute. Every test agrees. Time does not behave the way it feels. Feynman's warning was simple. Don't confuse experience with structure. Don't assume the universe is obligated to match your intuition. just because your intuition evolved to catch falling fruit and avoid predators. Science advances by abandoning comfortable pictures when they stop working. First, we gave up the idea that Earth was the center of the universe. Then we gave up absolute space. Then absolute time. Each step felt like loss. Each one revealed a deeper order. Time feels fundamental because your mind is built to track change. But physics shows that change does not require flowing time. It requires relationships that can be ordered, constrained, and recorded. That's the uncomfortable truth Feynman kept pointing at. Time is not what you think it is, and it never was. The fact that we can even discover this, that we can test it, measure it, and use it to predict things with absurd precision, is not comforting. It's something better. It means the universe is intelligible, even when it refuses to feel familiar. And that refusal is not a flaw. It's the point.